You can use MATLAB functions bar or bar h to create a bar chart. The difference between bar chart and the line is that you use the height of the bar to represent the value in the function. For example, we're going to create a vector x. I'm going to use a linear space function to create a vector that covers from 0 to 2 pi with 20 points. And then I'm going to do y1 equals sine x and y2 equals cosine x. So I got two vectors. Now I can create a bar chart. So I'm going to use function bar with x and y1. You will see the envelope of the bar chart is a sine wave. You can also group two data together to create a bar chart with two values for comparison. In this case, I'm going to combine the two vectors y1 and y2 because y1 is a row vector, so I'm going to create a two-dimensional array with the two vectors. And then I can use a bar function to create a bar chart that has two values in groups. So one, you will see the envelope like sine wave, and the other, the envelope is like the cosine wave. You can also create the bar chart horizontally. In this case, you're going to use the bar h function. So if I do the bar h, x and y, 1, and you basically see the bar chart is flipped. And this will be the y value, and this will be the x value. In addition to bar chart, you can also create histogram. For histogram, you need one vector. So the histogram will create bins and then count the values that fall into those bins. The function is called histogram. However, before I use the function, I'm going to change the vector x into 100 random values. And next, I'm going to do the histogram of x. As you see, the histogram basically gives you an idea that those counts are almost the same. It's because this is an even distribution of those random values. MATLAB can also generate pie chart. Pie chart is a type of graph that divides a circle into sectors to represent a value as a proportion of the whole. The function used to create pie chart is called pi. And it takes a vector as the input. There are three scenarios. The first scenario is the sum of the input vector x equals to 1. And each value in x represents the percentage. Let's create a vector x. That's 0.1, 0.2, 0.3, and 0.4. And you will see that the sum of the four values will be 1. And then I'm going to generate the pie chart. Here you can see that the percentage values are the same as the values in the vector. The second scenario is that the sum of the vector x is less than 1. Then we will have an incomplete pie chart if we use this vector. And you can still find that the percentage is the same as the value in the vector. The third scenario is that the sum of the elements in vector x is greater than 1. Therefore, the x value will be normalized to the sum before it is used to draw the pie chart. I'm going to create a vector of 0.4, 0.4, 0.4, and 0.4. So you will see that all values are the same, and I will generate a pie chart that are evenly distributed. And those distribution percentage will be 25, and the 25 will be the normalization of x vector to the sum, which is 1.6.